Thank you very much for having me here, guys. It's great to be back this year. I was here as well last year, and I had a great time, and it's even better this year so far. So the title of my talk is Stay a While and Listen. This is a story in two parts. Half of it is about creating a company, and the other half of it is about creating software. So I'm about to cover the last 2 years of my life where I participated in growing Undead Labs, the organization, into what it is today. Talks about problem solving primarily. Sometimes solving problems which you can't fix with an editor and a compiler. My primary role is a software engineer, but that's not always how you can fix everything. A little bit about me. I've been building and supporting online experiences for about 9 years. I've worked on Guild Wars 2, Lord of the Rings Online, Dungeons & Dragons Online, Terra, League of Legends, and most recently Moonrise and State of Decay. A little bit about Undead Labs. We were founded in 2009 by one of the founders of ArenaNet. ArenaNet created Guild Wars. I joined in 2013. I was about employee 20 or so, and now we're up to a little more than 50. Our flagship product was State of Decay. Its original launch date was June 5th, 2013 on Xbox 360. And now we re-released on Xbox One recently with Year One Survival Edition, and it's an HD remake of the original game. A neat thing is that the original game was created with about 20 people. It's quite difficult to create an open-world zombie simulator with 20 people, but they somehow managed it. Fortunately, I joined right after the completion of the game. Wish I could take some credit for that, because that is a huge feat. The next game that we began working on was Moonrise, and this is when I first came on to start building the online experience. Its codename was Kaiju, and it was a much different game when we first started developing it. But we always knew the original intention was to bring a AAA console or PC online experience to mobile devices. We later shifted focus. We took a step back from the game and realized what we had on our hands was something that you could play with all three major common gateway interfaces: keyboard and mouse, a controller, or a touchscreen. So we began instead pivoting and figuring out how we can get all those different platforms to play against each other, and again do it with as little people as we possibly could. One of the ways that we could do that is understanding that architecting, planning, and implementing is about 40% of an engineer's job, and the other 60% is team building and communication. Just a couple minutes ago, we heard, about from Martin, DevOps, continuous delivery, these buzzwords, and this is really all that is understanding that, again, you can't do everything with a compiler and an editor. I wouldn't have actually believed that a couple years ago, and I probably would have never gotten on a stage and told people that earlier in my career. That's because software doesn't solve problems, but people do. And it's because of this I'm trying to include a human element in my technical talks around this time now. I actually tricked you into listening to a little bit of a culture talk along with tech. A lot of times, the tech is like these marshmallows of the cereal. I don't know if you guys have this cereal here, but it's completely awful. And the only good part is the marshmallows. And that's the tech bits. And the rest is like this really shitty meatloaf. I don't know what the dieting habits really are of people in Poland, but everyone in America hates that. That's kind of an overstatement, just me, pretty much. So throughout this talk, I'm going to claim things are better or easier. But there's a little bit of a disclaimer. Better is within context. I'm coming from the standpoint of not just using and implementing a thing, but evangelizing it and observing the adoption. It's not always the best idea to choose the best solution if the people around you aren't going to pile on that as well. So let's talk about our problem at Undead. We have 50 people or so. And we need to stay development focused. We don't want to become a publishing studio. I'm not sure how many people in here are very familiar with game development, but a lot of the talk's going to include some of that because that's what I'm most passionate about. But developing games isn't just creating it. You also need to market it. You also need to distribute it. You need to go through ratings boards, and you need to have people want to be playing it. And then if it's an online game, you need to run it. And that's often takes large amounts of people. So we want to stay development focused, and we also want to transition from a single player to a massively single player creating game studio to creating massively multiplayer online games. We also want to build a positive relationship with our publishers so we don't become a publisher and have to do it ourselves. And we also want to develop and maintain a strong company culture. This is really important because we, as I previously mentioned, only had 20 people. And if you're creating another game and your original timeline was like a year and a half, which definitely did not take that long, way more than that, you need to hire people at the exact same time. And that's really hard. You want to make sure you get the right people. Transitioning and growing comes at a cost. So you need to make sure you develop your company and not just your software. We know that we had to grow the team, so we had to hire very carefully. And one of the ways we did that was making sure that we hired engineers and not programmers. This is a very important but subtle tip. Engineers are problem solvers. Hire people who can get work done regardless of the language or the framework they need to use to get it done. Engineers never say, that's not my problem. They see a problem and they say, I can solve that, and I can organize my teammates to help solve that problem as well. If you also want to stay development focused, don't be scared to contract work out. I know that Poland, a lot of developers here work as contractors, and that is great. I've worked and had great relationships with developers outside of the organization at Undead, and they've gotten a lot done for us. A lot of Year 1 Survival Edition, the HD remake of State of Decay, was assisted by developers outside of Undead Labs, and I don't think we could have did it in the time that we did without them. Wow, what was that? This isn't falling down, right? Okay, good, we're all right. And another big important tip about hiring is never hire a maybe. If you're growing your team, sit on the interview panel, get good at interviewing. And if you're talking with someone and you say, I don't know, but they know how to code in this language, or they're really good at this framework, don't hire that person. There's more people that are like that, or there's somebody better that doesn't know it yet, and you can show them. When you're interviewing, you should interview for these 3 traits. And this is very important to growing any team that you want. You should interview for IQ, which is intelligence, EQ, which is emotional intelligence, and personality. Personality is the bit like cultural fit. Is this person culturally going to fit into the company? Going to fit into the company's culture. And EQ is actually huge, which we normally look over when we're hiring engineers. We say, that's a great engineer, but he can't talk to people. That's a bad engineer. Don't hire that person. They need to be able to communicate with their teammates around them and sympathize and empathize with them. So, also staying small, and this is where DevOps starts to come into things, is you need to develop smart and be pragmatic and iterate. And don't have not invented here syndrome. Don't be afraid to leverage open source, and don't be afraid to be a good citizen in the open source community. Creating open source software and contributing back to open source software is going to make your company better in the long run. And that's really hard to convince some companies. Some companies, they wrap their lack of desire to contribute into open source in security questions and mystique. Like, oh, we can't contribute because it'll give away our company secrets, or they'll know how we do this. But that's not really a good idea. You need to get out there and start influencing the projects that you're using. It's very important. And those projects need to be the right tools. Adopt the right tools for the job and the right patterns. For instance, are you building a distributed system? This was a problem that we had to overcome at Undead. We're building a very large online game. It's going to be the basis of our future titles. So we're building a distributed system. A really great choice for that is Erlang. I know a lot of people here may be familiar with Erlang or OTP, but I want to also give this talk to people who are curious about why we would choose this solution, this language to solve our problem. So before I said we're going to use Erlang, or before we made any choice about what we were going to use, first we discussed with the team, and we instead thought, what is the right languages, or what are the right tools for our job? So I came in, and I'm, of course, giving this talk, so I believed that Erlang was the right choice. But we went through and we looked, is C or C++, C#, Python, Ruby, what is the right choice for solving this problem? And you might ask, why Mono, by the way? Why not just use .NET? But one of the problems that we had is that we need to live in the cloud, and again, stay small. And managing a large cluster of Windows nodes is expensive and can be difficult, especially if you're leveraging open source technology like Chef, where it definitely works, but the community is mostly not using it. So C would have been a great choice because game engineers are generally very experienced in C-like languages. And Mono, again, was a great choice because C into C# is very similar, at least the syntax is the same, and game developers typically will be familiar with C# and Windows environments, and using Mono is not very much different. We looked at Mono and said, this might not be the best for a distributed system, but this might be great for instance game servers and game-related code. Especially true because we chose the Unity game engine for Moonrise. And you can build Unity games in C#. So this would be great for instance game servers, but we want to get a lot done without many people, and we don't want to re-implement a distributed framework like OTP, which comes with Erlang. OTP is a extension to a standard library almost, and it gives you many libraries for distributing, for working with distributed systems. Process monitoring, RPC calls. You can actually, with Erlang and OTP, turn on two completely separate computers that are running two completely separate Erlang VMs, connect them together, and start a process on a remote machine from yourself, then monitor it, and actually think that you started it on your own computer. And it's all very seamless. So when we were having this discussion about which technology to use, it was very easy to say, we don't really want to build our own web framework. I'm sorry, we don't want to really build our own framework of distributed computing. Let's just try to use OTP. We wouldn't build our own game engine either. Like, we can, but some of us have shit to do. So especially at a startup, you have lots of things that you need to worry about. So Erlang and OTP save time, a lot of time. So we ended up making a decision. These were some of the perks that we brought up to the team. Erlang OTP network programming rules. Basically, you can easily encode and decode binary messages. You can monitor and subscribe to open sockets. You get free internal routing of messages, like I had mentioned. You have the two nodes, and it looks to you like you're sending a message to something that's on your own machine. It has the same threading model. If you're unfamiliar, it's single process, single threaded, and it's crash resistant as well with a supervisor hierarchy. Problem with Erlang is that it wasn't very approachable. And this is like honestly true. I think the language is amazing, but it looks like Prolog. And I have no problem ending my statements with a period or a semicolon, but it's really difficult, a big barrier to entry for people that are used to C-like languages. And it's functional, so if you're unfamiliar with functional languages, then you get a problem there as well. So we turned to a language called Elixir. Elixir is actually developed right here in Krakow by Jose Valim, and it's a wonderful language that's built on top of the Erlang VM itself. Elixir has all the same core concepts as Erlang, processes, mailboxes, supervision trees. It uses pattern matching, which is brilliant. I don't really want to touch a language that doesn't have pattern matching anymore. And it has tail recursion, optimized for tail recursion. So we started using Elixir at 0.90, and we had to ask ourselves, is this a risk? It's not a 1.0 language, and it's developed by a very small community. No one knows it. A lot of people didn't even know Erlang at our company. But like any decision that you're making, you need to weigh the risks. And one of the things that we looked at was its solid two-way interoperability. Basically, calling Erlang from Elixir and calling Elixir from Erlang is so easy, and that made it simple for us, a simple decision. This is Elixir calling Erlang. If you're familiar with Erlang syntax, that's not it, but that's calling directly the Erlang function. And you didn't need to fool around with compiler settings, you didn't need to fool around with packaging, it just works. And then this is Erlang calling Elixir. That's an Elixir module, and the bottom is what it would look like in Erlang if you were calling it. Notice the period at the end, and the engineers at my company were not enjoying that. So that brings up, so the period brings up the conversation of syntax doesn't matter. This is a thing that whenever you're choosing, a new framework, Chef, you're choosing a new language like Elixir or Erlang. It doesn't matter if it's beautiful, a lot of people say, but it really does, because you're not the one that's going to be learning this on your own. You're not the one that's going to be learning this without the desire to be learning it. You're going to have a whole team of people that are going to need to learn this software or this framework because you've made this choice for them. So Elixir syntax makes Erlang's ecosystem way more approachable for your colleagues. And that's extremely important because you need to have compassion when you're making these choices for your coworkers. If you know it's the right choice, you really need to make sure you foster that choice and make sure adoption gets picked up. Understand that when you learned that software, you really wanted to, and you already learned it, so you might not remember how difficult it was. Also, when you're making choices like this, make sure that the dev tooling is really good. It's not just the way the language looks or the way the framework looks. Is the tooling any good? So with Elixir, we have a build tool called Mix. Erlang has Concrete and Rebar, but they're really hard to use and set projects up with. Mix allows you, just like with Rails, to generate a brand new project with a single command. It also has a package manager, which is huge. Erlang does not have a package manager, but Hex now is beginning to support Erlang for the community. So this is all great. That covers some choices that we made on how we're going to build our software. But we're not just a development company at this point. We also need to run this. And how are we going to do that? We have 50 people, about 13 or 12 engineers, no operations team. What are we going to do? The publisher is potentially going to help run some of the services, but we want to keep a great uptime. We want to provide the best service to our players. So one of the things that we had to do was live in the cloud completely. Living in the cloud allows you to spin up on-demand test servers or complete environments. It also allows you to expand and contract your live cluster at will. This allows you to stay small and hire smart. It also allows you to host online game systems in a giant distributed system without going and building out an entire data center. If you want to support a new part of the world and you've already implemented for, say, EC2, you can go and put into a new part of the world. So if our data center today is in US West, we can immediately migrate into Ireland if we needed to. So I think everybody here is familiar with the word DevOps. But this is how we were able to operate, or we are currently able to operate without operations. DevOps is not a role that we have at Undead, but instead it's a development pattern or an ideology. It's the idea that you make operations every engineer's responsibility, or if you had operations people, you begin to help make development part of their responsibility. Using DevOps allows you to protect your culture, not overhiring, not hiring the hire that you need just because you need somebody to monitor your servers for you or spin up new servers. It allows you to also control your live service. By making this everybody's responsibility, it also allows you to not become beholden to a service organization with a monopoly. So if you've ever worked at a very large organization with an IT team, and this is nothing against IT teams, but sometimes, you know, it's not about supporting people anymore, it's about protecting the hardware. No, you can't put stickers on the laptop. Why? Because I'll have to take them off. No, you won't, I'll take them off. You can't do it. Why? Because I have the power. And it's kind of like that. So anyway, it also allows you to operate without the extra headcount. So you're saying, no operations. Who's going to build the machines? Well, a nice thing is that we're going to live in the cloud, so no one's going to need to put hard drives in anything. But then, even with the cloud, how are you going to create that? Are you going to point and click through? You could, and you'll be building one at a time. And then, if you need to kill that machine because machines are cattle and not pets, how are you going to do that? Well, there's a great tool that came out from HashiCorp. Seth Varga is going to be here later on today. Can't wait to see him. He's going to give us a talk tomorrow. He might cover a little bit of this. Contents are of his talk. Is my microphone cutting out? All right, sorry about that. But Terraform is a tool from HashiCorp, and it's a great tool. What it allows you to do is represent what your infrastructure would look like, the actual instances inside of EC2 and the security groups or the elastic load balancers or you name it. Like every artifact that you can possibly describe in EC2, you can represent this in code. And it is just brilliant to work with. After you describe it, you version control it, and you run a single command, and it'll turn up an instance on demand. I'm sorry, it'll turn up a environment on demand. It's modular, so you can describe what it looks like, for instance, to have your front-end servers and then your back-end servers, and then it understands the dependency graph between them, so it'll turn the back-end servers on before it turns the front-end servers on. It's just a brilliant tool. And then there's configuring problems. So we know who's going to build the machines, but who's going to actually go and configure those machines? Are you going to get on the machine and start editing the host file? No, fuck that. Are you going to go on the machine and start installing run it services manually? Not a good idea either. You can use this tool called Chef. There's a couple others out there, Puppet, Ansible. I'm a huge fan of Chef, though, because you can represent your infrastructure, again, as complete code and not instruction files. And it has an absolutely amazing community. So Chef's this configuration management tool, and it allows you to describe all the things on your computer or on your remote nodes, like files, directory services, and you can actually use it to deploy software. It's just another brilliant piece of the puzzle here. So both of these tools could have a complete talk in their own, and I highly recommend that you spend some time with these in your own time if you haven't already. We use Terraform to provision all of our nodes and Chef to bootstrap our nodes. And by describing our infrastructure as in complete in a code base, we can then share it with each other and turn on those environments on complete on demand. So another rule that we were going into through development was the idea that there was no such thing as a DevOps team at Undead. It was very critical that every engineer understood Elixir, OTP, Chef, Terraform, and any other automation tooling that we had to leverage the cloud. So with the introduction of Chef, we had 3 languages that everyone had to learn, basically. There was C# for Unity and for our instance game servers, Elixir for our entire backend, which I'm going to describe in a little bit, and then Ruby, because Chef is in Ruby. What was extremely important here is that not everybody knew these coming into Undead. These were choices that we were creating that engineers needed to spend time to learn. So a huge part was helping to foster adoption for our technology choices. Just choosing those technologies isn't enough because, as I said earlier, software doesn't solve problems, people do. So we spent special care to make sure that there were on-ramps for my teammates. And we wanted to create an environment that was safe to fail in. We created and evangelized patterns and standardizations. That allowed for collaboration between the different developers. We also performed code reviews extensively. We made it a very big part, not to make sure that people were putting the semicolon in the right place or they were using spaces instead of tabs, because any sane human being would do that. But instead, it's because this assists with the learning process. Don't think of yourself as the gatekeeper to the code base. Think of yourself as the ambassador to the code base. If somebody is contributing in and you have valuable feedback for them, give it to them. But stay positive in the tone in your code reviews. Stay far away from an authoritative tone. And generic praise is not enough. If you see something that somebody is doing that's good, and this is especially the first time that they've done it, don't assume they know that they're doing a thing that's good. They might have no idea and it's just an accident. So don't just say, that's good. Say, this is good because of this. And that person will remember, I do this because this is what's good. And one more time, avoid style discussions and syntax discussions. It doesn't help anybody. So that's the culture part. And then this little bit's going to be how we develop the software, what our service looks like, and hopefully give people in here a peek at what it looks like to create an online game. I know that Krakow or Poland has a growing online game community or just a game community. The Witcher 3 just came out or is about to come out here, I think tonight. Like if you go to the equivalent of your Amazon Locker service, you can get The Witcher at like 12 o'clock, and it's a brilliant game developed by a studio here. So hopefully this will be interesting for you all. So there's 3 components of an online game. There's a game client, there's a game server or servers, and then there's a service platform that the game servers then talk to. The game client's a thing on your personal device. It's a multi-threaded application. It draws the screen, sends and receives data from the game server. Typically, it's powered by a game engine like Unreal, Crytek, idTech, Unity. You can create your own. And then there's the game servers. The game servers simulate the game, and they negotiate with clients, and then they communicate with the back-end platform. Typically, game servers hold transient state, not persistent state. They're there to service your current game. So if you connect to a game world, you connect to a game server, the game server loads your data or your character record from a thing called a platform. And the platform should be game agnostic. It also should be highly available, and it's basically the stitching around the game servers or the experience. As you transition from game server to game server, you're not moving all of your data between them. Instead, you're committing your data back to the platform, and then the game servers are loading it out of the platform. And this provides services to games like auth, chat, presence, leaderboards, guilds, player profiles, and you name it. So BattleNet is a really good example of a game platform, if you're familiar with Blizzard games. So we called our platform Tubes because data goes through it. It's mostly written in Elixir. There's a few C# mono servers. They were written in C# partially because there was an arms race. 2 developers were working, myself and my friend, to figure out if Elixir really was a good choice. So some of the remaining C# servers could have or should have been implemented in Elixir. But it doesn't matter. They stitch together just as well, and it is a testament to that building microservices is a really good way to develop a platform or a distributed platform. And there's actually going to be a talk on building microservices either today or tomorrow, and I am very much looking forward to that. Oops. All right, so where do we start? And the answer is with only exactly what you need. So it's really easy, especially if you've done or built something before, to say, oh, I know all the things I'm going to need. I'm going to need to build this, I'm going to need to build this, I'm going to need to build this. The problem is then you get into the job of building technology for the sake of building technology instead of building an experience. So when you are first building out anything, game or you name it, you should identify a proving feature. And proving feature is a thing that can show somebody this is the basis of everything. So for us, that was presence updates from one player to another, like a chat server. This allows you to prove that data came into the system from the client to a game server to a platform, and then from one platform server to another, and then back out through another game server, and then back out through a client. And what this allowed us to do was set expectations with our publisher and help inform milestones. We said, this is, not the game. You didn't ask us to go build a chat server, but by describing what the importance of that chat server was, and then saying, but this will allow us to turn on these additional services later on, the publisher was actually very happy. So this goes back to communication. So it's important to communicate within your team, but it's also important to communicate with non-technical people and help set those expectations. So that way, people don't say, well, where's the code Jamie's been working on? Where's that service? He's been working on it forever. And then you're like, oh, I'll have it done in a day. I'll have it done in 2 days. That's not really helpful. Instead saying how long and why and what you're working on. And this is part of agile development, which is another nice buzzword that we can throw in there. So let's talk about building the main players of the platform. That was our protocol, our routing server, the lobby server, which holds a persistent connection, and then the chat server. So there's also a supporting cast of additional services that were required. These are the C# services. There's a spawn server, a match server, and a versioner. I'll describe those in just a minute. So the first set is the protocol layer. All of our servers speak TCP binary messages. The backend server engineers worked with the game server engineers to sit down in a room and decide what the protocol would look like that they spoke. And this is a breakdown of Undead server message anatomy. Basically, there's 32 to 96-bit message envelopes. There's a message ID with a fixed max length and a variable size body with a fixed max length as well. So the message envelope is 3 parts that are 32 bits each. There's a header info, routing info, which is optional. You only provide this if you're talking to a routing server, and then transactional info, which is only if you're sending a message that you expect to have a response on. Inside the header information, there's 1 bit of routing information, which will tell you, is this a routed message? So that next 32-bit packet, is that expected or not? The transaction info bit, which is that third packet expected or not? 4 reserved bits. Then the message ID length, which is 6 bits, will tell you how long the message name that you're about to receive in is, and then the body length, which tells you how long the message is going to be to expect to be receiving. So this is what the binary looks like in Elixir for the header field. If you've ever seen Erlang or Elixir before, this is pattern matching at its best. On the left side, we're describing a 32-bit message. And on the right side, we're describing the parts. This looks exactly like the slide that I had just showed you. And this is actually the code, though, that unpacks the message. Using pattern matching, you're able to extract out a 32-bit message into these 1-bit variable and the has transaction variable, or the reserved, or then again, the message ID and body length. So using this binary pattern matching is way more than using, it's way more intuitive than bit shifting. So the next bit was the routing field, or routed messages. These are optional, and they're special types of messages that the Undead protocol can speak, specifically meant to be sent to a routing server. The routing servers are in tubes, and they sit in front of all the other services. And this was, again, optional, but it's 22 bits is a routing hash, and then 10 bits is the protocol ID. The routing hash is how we accomplish sharding. So if I say, there's 128 shards of data, and I want to send a message to somebody on shard 7. We use deterministically random routing to figure out, oh, this person's always on 7 because I gave this specific route hash. And then the protocol ID is specifically saying, I'm either talking to chat, or I'm talking to Vault, or Wallet, or another one of the services. And again, oh no, is this on? Yes. It's just as simple as pattern matching again. And then I spoke briefly about the transactional, the non-transactional messages. Non-transactional messages are very simple. They are like a cast. You just send it, and you say, I don't care about that. And then transactional are a call. You send it, and then you wait for a response. Transactions complete when the client receives a message with the transaction complete set flag. Transaction complete flag set. And it can also receive additional messages for the transaction. So for example, if I said, I want my friends list, that's a transactional message, but there are additional parts of that. So if I say, what's my friends list, it'll send me a message back that says, here's a friend, here's a friend, here's a friend, here's a friend, that's your last friend. And that last message will have the flag set complete. The client will automatically time out on long-running transactions. It's important to note here that the client is not the game client, but the game server. The game server is the client to the routing server or the platform. And the client can also receive a transaction message, extension message to avoid that timeout. So if I say, I got you, I'm getting your data, wait 20 seconds. Wait 20 seconds. I still don't have it yet. Wait 20 more seconds. So that way the client knows that you haven't gone off and forgotten about it. That last bit is the description about, for instance, how you can receive your friends list. So the transactional message is broken up into 32 bits again. One is this a response to a transaction? 2, is this a partial response or a complete response? And then the last bit is a transaction ID, so the client knows this is a response to this particular transaction that I sent out. And this is what that binary would look like. So we needed to make it easy to define and handle new messages, since this is a core lifeblood of anything that you wanted to do in the back end. And one of the ways that we did that was leveraging Elixir's macro system. So this is a protocol message definition for chat. This is for sending a whisper. There's some other information here that we can unpack. We can discover that chat is protocol ID 1. So whenever you're sending a message to the routing server that you wanted to be talking to chat, you set protocol 1. And then the other fields are validated. So we know that we have a sender ID, a receiver name, and a tag, and some content. And the name of the tag is how we identify who that person is by name in the cluster. So those macros made it easy to define a new protocol and a new protocol. And you use those protocol messages in our handlers, and I'll show you those in a little bit. So the lobby server is actually the main client of the routing server. This is the thing that the clients are going to connect to, and this is written in C#. Again, it's transient state. It doesn't really matter. It doesn't store anything about you until you persistently you log on. It loads your data from the platform, and then you log off. It's your persistent connection, the one connection that the client has into our cluster at all times. This also negotiates with the core platform services like auth, chat, presence, the bare necessities of what you need to be able to get into the game. It's multi-tenant, so multi-clients connect in, and then the lobby server connects to one routing server and negotiates for all those clients. Again, it's a client to the routing server. So, hello, yes. I'm going to not move. The routing server is basically a ranch listener, which is a library from the Erlang ecosystem that allows us to, again, easily leverage TCP connection pooling. And what it does is it peeks at that message envelope, the header. It doesn't unpack an entire message. It just cool. All right. It just reads the first 32 bits of every message that comes through, and it says, oh, is this a routed message for me? Okay, it is. What protocol am I speaking? Okay, what is the route hash? And then it knows how to send that message along to the appropriate shard in the service. It tags the message with the protocol, the socket ID of the connection, so that way we know where the client is in the Erlang cluster. And it also performs a job of disconnecting misbehaving clients. So for instance, if somebody had somehow connected to one of our backend servers and started sending too many messages or trying to flood us, this will turn it off and then alert us about our problem. So the main module here is a listener, the TCP listener. And this is basically how to start it in Elixir. Again, Erlang libraries can be used completely without much hassle. It is as simple as writing this one line to start an entire TCP listening pool. So let's talk a little bit about establishing the connections from the client to the lobby and the lobby to the route. So client to lobby is pretty simple. First, the client needs to connect and figure out what lobby version it needs to talk to. The client has its own version. So it connects to a thing called the versioner server, also written in C#. And the versioner is a way that we can allow multiple versions of the client to run without forcing somebody to patch. If you've ever played an online game before that patches often, you have to sit at the patcher before you're allowed to play with the other players. Some games, like Guild Wars 1, allowed everybody to just log on and play, and then sometimes it would send you a message that says, there's a new version of the game available. If you log out, you can download it. And this is how we accomplished that on Guild Wars 1, and this is how we're accomplishing it on Moonrise and future Undead projects, by allowing clients to still connect until we say, that is a bad version, and then turning the version off for us. So the versioner talks to match server for the location of the appropriate lobby that is running your version. If match doesn't find a lobby server, but it's a version that we still support, it talks to a server called spawn, which spawns the appropriate lobby server. And then the versioner caches that response so then it knows forever where that lobby server is until the lobby server shuts down. The versioner tells the client where the lobby's address is, and then the client connects to the lobby. So once the client's connected to the lobby, it needs to then still get into a game. The lobby has nothing to do with playing a game. What it has to do is keeping your persistent connection and then arranging for you when you ask to join a game. So lobby talks again to match. It says, this is the version of the client that we're speaking. Is there a game available for them to join? If not, it talks to the spawner, spawns a version of the game. Then it comes back and tells the lobby, here's the version of your game server, and here's the address. The lobby then tells the client, here's the address, and the client connects to the game server with a special reservation token that then makes sure that people cannot connect to a game server without being authenticated. So lobby and game, again, are clients of the route server. So let's explore the logging in and whispering to the chat server. That was a bunch of prerequisites that we had to create just so we could send a very simple chat message between two players. And we could talk about that feature now. So quickly, we can talk about routing the message. The first thing is a struct in Elixir. This is what the message that we define macro looks like in actual usage. Again, there's a account name and tag, which is who we're going to be messaging, and their account ID. And the acceptor is a very important part. That is, when the message came through the routing server, it got tagged with a PID, which is a special term in Erlang that then says where in the cluster the node, or specifically the requester, lives. So if I'm on a completely different server and I have this PID and I send it a message, Erlang will take care of all the work for me and send it all the way back to that route server, and then that route server will broadcast it back to the client. This message will be routed to any chat server that we, in the cluster, based on a route hash And the route hash is the key. So for instance, here would be account name. We want to figure out where this player is by whispering to him by name. So this is a dispatcher. Once we get on the chat server, the message gets routed through the routing server to the appropriate chat server. This is how the chat server figures out how to handle that message. So we see that we have this handle message call, and we're, again, pattern matching on the login message. We're doing a little bit of unpacking and sending the message login with the request. And then if they were logged in, we send a message back to complete the transaction that says it was a success. Or if, for instance, they are banned, we send them back a message that says they were banned. And in the previous slide, you see that we're using a net dispatcher, which is a behavior. And behaviors are a thing in Erlang or Elixir, which allows you to create reusable patterns in code. Simply, all you need to do is you say use net dispatcher, and all of a sudden this module is given a bunch of different functions that kind of like an inheritance in Ruby, or modules in using include in Ruby. The net dispatcher creates a registered process, and you basically implement handle message callbacks matching the protocol messages. And what it does is it quickly dispatches the messages coming into a worker process. And what that allows us to do is any message that comes into the cluster gets its own process that spawns, its own thread, that then goes off and does the work for us. So that way, we're not creating some sort of bottleneck. So I'm going to dissect the handle message just a little bit. The net error success actually does mean success. Net error is just a type that we use internally as a response message. And then the banned message contains a unique string that is not useful for the end user, but displayed to them in small text. So that way, an engineer that sees it knows why the player got a particular message. So we might not want to tell them they were banned. The server wants to tell them they're not able to log in, but they can contact customer service and say, I got a ch login 1 error. What does that mean? And like I said, it's kind of poorly named. It should be maybe net response, but this is kind of legacy from a bunch of engineers that worked at ArenaNet. And it contains those two parts, which is basically the code and then the unique message. So let's look at logging in and subscribing. So the last we had handle message. Handle message then talked to chat user login, and it passed it the login protocol message. This is simply a process turning on and linking. So you have chat presence feed, which starts up. You have it loading your account and storing your state, completing the login transaction, but first loading all your friends and setting them down to you. And then if we lose a connection to the lobby server, because we looked at the acceptor that came through from the route server and we monitored it, we were able to say when the acceptor goes down, we know that we need to shut down. That player is no longer there. They're no longer connected. So we also can send an update out to our other friends that say, our user is now offline. So this is the core concept of presence. Presence is basically I came online, I logged off, I sent a message, I received a message. The handlers are removed if the process is shut down, and the user process is shut down if the primary connection was terminated. So this is sending a presence notification. So if the user comes online, we need to tell the user, the other users or friends that the person came online or that they went offline. So this is the protocol routing module, and this is how we send that message directly to the client. So knowing that PID, we send a message with client send to the PID. We encode the message using our encoder or decoder, and we cast the message off. So once we send the message off, we need to forward a presence notification. So this is the connection handler from the router. This is what you had connected in, and this is how we know where you live, what lobby server you're on. So we handle a send message. We do a little bit of time crunching to make sure that we reset when's the last time we heard from the user, and we route the message out to the player by sending the data. So this is all good. This would work on a single node. This is just the basic feature of a chat server. But you need to distribute this out. And this is really the bread and butter of why we had chosen this language and this framework to implement our backend server. And when you're distributing a service out, there's a couple different ways you can do that. But one of them is with data sharding. Data sharding, often people hear about this in databases. And this is the core concept for just having a persistence layer that pre-buckets out where data goes. So we pre-shard our data into X buckets. And for us, buckets are Postgres databases, or specifically Postgres databases with schemas in them. And we pre-shard by 128 times. The Elixir applications act as service maintainers for the shards, or the buckets. And they broadcast what shards they support to the routing servers. So if a chat server comes online and it knows that it supports shards 1 through 15, it tells the routing servers. So the routing servers all know at any time which chat server they should be sending a message to based on what shard they're supposed to be talking to. So if you're on one server and you need to message another chat server, you don't know where the other chat servers are. There's a problem in Erlang, which is that all nodes, when they connect to each other, are fully meshed. Fully meshed nodes have a problem. You can only connect maybe 100 nodes together before it starts to fall down. So the important thing here is that the routing servers know where everything is, and you know where your routing server is. So you send a message to a routing server, and it gets bounced off and then sent to another chat server. This also allows us to hide complexity from engineers. It allows us to make people think that this is just regular old Erlang or Elixir that they're talking to. But really what they're talking to is the net dispatchers that then spawn a worker thread and allow you to process your message just like if you had sent a message in from a lobby server or a client. This is what the net module that we have looks like, or the API. This is what is exposed to the end users, the engineers, when they are wishing to send a message to another chat server. The first argument here is the protocol you're going to speak, say chat. The next is the route key, what you're going to route on, and then the module function and the arguments to that function you wish to call. This is a way to do distributed RPCs within a giant cluster. And this is a very simple implementation of that. This is how you would basically send a whisper from one player to another within the chat cluster. And this is known as deterministic routing. Basically, we know what shard the message goes to because it will always go there. So if I mod and hash the word Jamie, I may get shard 22. And it will always be shard 22 because I don't know that it's going to be shard 22 until I run the function. But once I know it's always going to go to shard 22. So inside of our Postgres schemas, we create entities that contain the shard ID, which is embedded in the ID of every object. So we actually took all right. We took this technique from Instagram. And basically, every single object that we create in our backend, you know where it had came from because embedded in it is the time in which it was created and also what shard it came from. So this is actually a function that would extract that data out. It's a 64-bit integer every ID in the cluster. The last 13 bits is the shard ID, and the first 51 bits is the time in which it was created since a particular epoch date. We also use randomly deterministic rounding, which then says we don't know what shard the message goes to, but it will always go there. And this is the functions for that. So you would hash a value, and mod it against a particular divisor, which in this case is 128 for the amount of shards that we have in a cluster. And we use the FNV1A hashing algorithm to figure that out. It's very quick, which is one of the reasons why we chose it, and it also has a very low collision rate. So every routing server has a shard directory. And the shard directory is where the application servers connect to and say, I support these 15 shards. And when we are going to send a message, we peek in that shard directory to identify the Erlang node which services the shard and protocol combination. So I say, I need to talk to chat server 15. Where is that? And then it tells us. And one of the ways that we populate the shard directory, or the way we populate the shard directory, is with a tool that we call Discovery. Discovery is the how we automatically discover and connect to Erlang nodes or Elixir nodes. We actually open sourced this, and this was the very first piece of technology that we built on another HashiCorp tool called Console. This was extremely powerful for us because it allows us to no longer manually configure our servers. So we still use Chef to configure the nodes, but we don't ever enter IP addresses anymore, or we no longer enter DNS records that says this is where all the chat servers are. They just connect in and then use Console to gossip about where each other are. And then the routing servers discover from that and then populate the shard directories and say, oh, these are all the chat servers that we have, these are where all the shards are, and it's all done automatically. It also allows you to turn services on in any order that you'd like to. So if a routing server comes on first or a chat server comes on first, it doesn't matter. They'll all automatically figure out where they are. And if any of you in the room have not used Console before, but you're application developers, I strongly suggest using it because it makes the burden on your operations team much, much, much lower. So this is going to be a quick breakdown of Discovery. I'm running a little bit out of time here. You can find all this online at Undead Labs /Discovery on our GitHub. But basically, Discovery is broken into 4 parts. There's a polar events, a handler, and a heartbeat. The heartbeat says, I'm still alive. The polar says, I care about this type of service. And the polar events say, when something happens, this comes online or goes offline, do this. And the handler is the actual module that implements the functionality to do a thing. So for instance, in the chat supervisor, we care about routing servers. And when a routing server comes online, we want to broadcast what shards we have to it. We also want to tell the cluster we're still alive. And the route connector is the module that we use there to then say, oh, when the routing server comes online, this is how I connect to it and make sure I stay connected. So Discovery, thanks to Erlang, also automatically reconnects nodes which became disconnected. So this is going to be a very quick breeze through of the overview of what the actual game servers look like. They're instance and distributed. The first one's the world server. You connect to it, and it's basically your town. It's a quest hub. It's where you would connect with players and say, oh, do you want to go on an adventure? Do you want a PvP? It's basically player interaction, chat, and store. Then there's the combat server. So say we were in town, we challenge each other to a PvP match, and you load into a combat server. Again, these are all completely instance, separate with transient data, and the matchmaking happens, and then it loads your data from the back end. Some of the other services that power this are the admin server. The admin server is basically how we kick and ban players. It's the administration stuff. It's how we give people lost items, things like that. The catalog server, which is how we populate the store. It provides the purchasable items, the friendly name of things, and it does that to the game client. There's fulfillment, which after you've gotten the item list, you want to purchase something. If you make a purchase, we don't process any payments. You instead go through Steam or iOS or Android store, and then you get a receipt back and you sell fulfillment. I just bought this, and it says, did you? And it goes and figures out if you did. If it did, it delivers the items to your mailbox, which brings us to mail. Mail is players sending mail to each other, or specifically, if you purchased an item, it'll automatically deliver it to you. It's basically how we can do asynchronous message between when you're online or offline, and it's a persistent store. There's a notify server, which sends the push notifications. So, for instance, if I have a PvP challenge, my phone might buzz in my pocket, or my watch might buzz if I ever make a Moonrise app for it. The Vault server, which is probably where most of the work went, this is where all the player data is stored. And this is, again, broken into 128 shards. It's completely game agnostic, so any game can use it. It's storage for character data, inventory, things like that, and later when we implement guilds. All services are exposed to the same API, which is extremely important. They look like you're using the same service, but under the hood, they're all completely different. So some fun additional problems that we had to solve were, how did we make the releases for the Elixir apps, especially early on when Elixir was brand new? I think we were one of the very first people to create an entire release and then deploy it out in a production environment. I brutally hacked schema support into the database connector library in Elixir, and then also figuring out how to do game-agnostic fulfillment for Kindle, iOS, Android, and Steam. What's next is automatic shard migration. Basically, you have 128 shards, and you have potentially a service that goes down or a database server that goes down. How do we migrate the data between those shards? How do we rebalance shards? For instance, if the hashing algorithm that we're using fails us and one shard begins to get overloaded, how do we migrate players off? Additional esports features, guilds and communities, and of course we're always trying to improve performance. Currently running load tests and trying to get our load up. We're going to launch next week into early access. And this is my contact information. I know there's a lot of tech here. It's a really in-depth talk about a language maybe people are not very familiar with, and about a subject matter which is also maybe not very familiar to people. But I hope you had a great time, and I hope that you have a great time at the rest of your talk. And thank you very much for the people running AV. This was great and very easy and painless. Thank you, everyone.
Does anyone have any question?
Oh, so it's in the speakers. So the question is, like you said, that you worked on like 5 or 6 games in a couple of years. So you obviously have tight time limits, tight schedules. So in such, well, I'd say that I would be anxious in such situation because I know that I have to deliver in a year or maybe in 2 years. So how in such environment you manage to adopt such technologies? Because you said that it was a risk to adopt Elixir, so you just decided that, okay, so for 3 weeks we decide which technology to use, and then we use this technology. Or you just, okay, we take this risk and whatever happens. So how do you do this?
So all of software development is about risk mitigation. The problem there is that you can be paralysis through analysis. If we sit for too long and debate about what is good and what is bad, then we'll never get anything done. So instead what we do is we come up with our best case scenario with a failover. So if you remember, I had mentioned that I was working on the Elixir backend while another person was working on some of the backend in C#. And we did that as a failover. If one of us failed, then we'd say, oh, that's a good solution, we'll use that, or that's a good solution, we'll use that. Another reason that we went with Elixir is that we could have always fallen back to Erlang, and that was a large part of the risk mitigation conversation. But yes, there's always very tight deadlines, and there's always a chance that you can fail. But by communicating with the people who are, like say the publisher here, you can say, we're doing these things with hopes of this, and then let them know about the risk that you're taking. And hopefully, you don't fail. That's not to say we did not have plenty of failures. I'm going over a whirlwind tour of this and glossing over many mistakes that we did make along the way. Yeah.
Elixir is a very young language, and as far as I know, it started with a one-man project. Weren't you afraid that you become lock-in with a particular technology that will one day become no longer supported, and you will be, you know, with a stack of technology that nobody supports, and if you find some critical bugs, you will not be able to fix them?
That is a great question. There's two reasons. One is the interoperability between Erlang and Elixir. Even if Elixir died, we still could have called the Elixir code from Erlang whenever we wanted to, and slowly migrated stuff off way easier than it would have been to migrate, say, Python to Ruby, which is, again, possible, but still difficult. You're not living in the same ecosystem at that point anymore. That's one. And the other one is the community, just like Chef's community, is extremely open. I've yet worked with another language where I could influence the direction as easily as with Elixir. Jose, who lives here, I'm going to have a beer with him hopefully today or tomorrow, and he actually released a version of the language for me, or our company, just because we had a chat and I said, this is not working out. And he said, that's right. That's something we wanted to do later on. And he prioritized it, went home for a weekend, and made it, and then gave it to me. It was quite amazing. So, is that, yeah? All right. Any more?